This is the video solution to practice problem A that accompanies sample problem 1.4 in your text. This problem appears on page 16. The question asks us to determine which of the following processes is a physical change. There are lots of definitions and examples on the previous pages of what constitutes a physical change and what makes a chemical change. To answer this question effectively, we'll need to focus on matter at the atomic or molecular level. Molecules are groups of atoms bonded together in some way. The bond is the glue that holds the atoms together. A chemical change will always involve a change in bonding between atoms. A physical change does not involve a change in bonding. So as we look at the situations that follow, we'll ask ourselves this key question. Does a change in bonding occur? In part A, we'll examine the evaporation of water. First, we have to imagine molecules of H2O that might look like this. Hydrogen is in white and oxygen is in red. In the liquid state, those water molecules have a small amount of space between them and they're in constant motion. When the sample evaporates, we end up with H2O molecules in the gaseous state with much more space between them. But our molecules, specifically the bonds between the oxygen and hydrogen atoms, have not changed. So we should label this as a physical change, and any change of state will be a physical change. In part B of this problem, we need to look at the combination of hydrogen and oxygen gas to form water. I don't expect you to know this right now, but hydrogen and oxygen gas are actually diatomic molecules. That means they exist in groups of two. We could imagine a sample of hydrogen gas like this. This would be two molecules of H2. And oxygen would look like this. This would be one molecule of oxygen. When these molecules form water, we definitely have a change in bonding. The original bonds between the hydrogen atoms are broken, as well as the bond between the oxygen atoms, and we get new bonds that occur between the hydrogens and oxygens themselves. We would call this a chemical change. Part C asks us about the dissolution of sugar in water. The word dissolution means to dissolve. So what happens when sugar dissolves in water? Does bonding change? We've already seen water molecules, but molecules of sugar are a little bit harder to visualize. I'm going to show the sugar molecule as an oval-shaped molecule. It's actually a combination of carbon, hydrogen, and oxygen atoms with bonds between the atoms. When sugar dissolves in water, the sugar and the water molecules mix together. There's no change in bonding. There are a couple of ways we can know this. We know that the taste of the sugar molecules stays the same when they dissolve in water. Their flavor remains in solution. And if we were to remove the water, maybe by evaporation that we just looked at, then the sugar would remain. There's no change in bonding here, so we will call this a physical change. Part D, the separation of sodium chloride into its constituent elements. In other words, taking apart sodium chloride salt and forming sodium and chlorine. This is pretty easy to visualize. Sodium chloride is a combination of sodium and chloride that looks similar to this. If we imagine this solid separating into sodium and chlorine is diatomic as well, then we would find this, or something similar to it, as our final picture. We've got new bonds that are formed between the chlorine atoms, and no molecules per se of sodium. This is definitely a change in bonding, and we will therefore label this as a chemical change. Finally, we'll consider the combustion of sugar to produce carbon dioxide and water. We've shown sugar as a purple blob containing carbon, hydrogen, and oxygen atoms. If this were to undergo combustion, we're told that we make carbon dioxide and water. This change would involve a complete rearrangement of the atoms and the bonds in the sugar to form the smaller molecules that we see on the right side of this picture. These would be new compounds. This change in bonding then should be labeled a chemical change. Ultimately, there are two answers to this question. Both A and C are physical changes. Let's just quickly review. To answer a question like this, think about matter on the molecular level, and then ask yourself the key question: does a change in bonding occur? If the answer is yes, then you're looking at a chemical change. If the answer is no, then you're looking at a physical change. At this point, please take a moment and do practice problem B on page 16. The answer to this question appears on page 33 of the text, and let your instructor or your TASL leader know if you have any questions.